Coulomb's law. One winter afternoon, a student named Ananya was sitting at her desk studying when she noticed something strange. After combing her dry hair with a plastic comb, she placed the comb near small pieces of paper on the table. To her surprise, the tiny paper pieces jumped toward the comb and stuck to it. Why are the papers moving toward the comb? She wondered. Curious, Ananya rubbed the comb against her hair again and brought it close to a thin stream of water flowing from a tap. The water bent slightly toward the comb. Now she was even more confused. The comb wasn't touching anything, yet objects seemed to move toward it. The next day in physics class, she asked her teacher about the strange effect. The teacher smiled and explained that when Ananya rubbed the comb on her hair, it became electrically charged. Objects around it also had electric charges, and these charges could either attract or repel each other. He explained that two charged objects exert a force on each other even without touching. If the charges are opposite, they attract. If they are the same type, they repel. But the strength of that force depends on two important things: the amount of electric charge on the objects and the distance between them. This relationship is described by Coulomb's law. The teacher explained that the force becomes stronger when the charges are larger and weaker when the distance between them increases. In fact, if the distance doubles, the force becomes 4 times weaker. Ananya immediately understood what happened with the comb. When she rubbed it against her hair, it gained electric charge. The charged comb then exerted a force on the tiny pieces of paper and even slightly pulled the stream of water. That simple experiment at her desk had quietly revealed a powerful rule that governs electric forces everywhere, from tiny particles inside atoms to lightning in the sky. This story shows that electrically charged objects can attract or repel each other even without touching. The strength of this force depends on the amount of charge and the distance between the objects. This relationship is explained by Coulomb's law, which describes how electric forces act between charged particles.